Hey guys, this is Yaguan from Group 5. This is a quick overview on projectile motion. First of all, what is projectile motion? Projectile motion is the curved path or parabola that an object follows when thrown or propelled near the surface of the Earth. A projectile, on the other hand, is a body thrown with an initial velocity which it is then allowed to move under the action of gravity alone. A projectile motion is resolved into horizontal and vertical components, which are independent of each other. I'll call them X and Y components respectively from now onwards. There are two major cases of projectile motion, namely projected horizontally and projected at an angle. Before we go any deeper into these two, I'll be covering a few things that you should keep in mind when tackling this kind of situation. The velocity for the X component, Ux and Vx, will remain constant throughout the motion. This is because there is nothing acting against the body, and hence the acceleration for the X component, Ax, is equal to 0. For the Y component, on the other hand, the acceleration Ay is always constant, which is always negative 9.81 meter per second squared. When the object is at maximum height, the velocity for Y component Vy is equal to 0. One more thing is that when the object is at the same level, they have the same resultant velocity. Back to the two cases of projectile motion. For the projectile motion that is projected horizontally, the diagram of the motion should look like this. What you can obtain from this diagram is that the initial velocity u will equal to the initial velocity of X component ux, while the initial velocity of Y component uy equals to 0. On the other hand, for the projectile motion that is projected at an angle, the diagram of the motion should look like this. Here you should resolve the initial velocity u into X and Y component. With this, you should get this. From the diagram, you can see that hash is the maximum point of the motion. From this, you know that at hash, the Vy equals to 0. With this all said, we shall hop in and try some question. I'll jump straight into the explanation and the solution, so feel free to pause the video and read the questions. Alright, the first question. From the question itself, there are several information that you can extract. I'll list them all out at the side here. Let's jump into part A. Calculate the time taken for the ball to reach B. As we have adequate information from the question itself, we can use one of the linear motion equation to solve this question. In this case here, we will be using the equation s equal ut plus 1 over 2 at squared, and we will be using the values for the y-axis. Substitute in the values, rearrange, and you should be able to get the answer. Next, part B. Calculate the horizontal distance x. This question wants you to look for Sx. In this case here, we have to use the same equation for part A, but this time we'll be using the values for the x-axis. Substitute in the required information provided in the question itself and part A into the formula. Press your calculator and you should be able to get your Sx. Alright, part C here requires you to calculate the magnitude and direction of the velocity at B. Velocity is a vector quantity, so it has both magnitude and direction. So to tackle this question, we shall resolve the velocity into x and y component. For x component, we know that Vx is equal to the Ux, which is equal to 5 meter per second. As for the y component, we have to use the linear motion equation to get Vy. In this case here, we'll be using V equals to U plus At. Substitute the information required and you will get Vy equals to negative 4.41 meter per second. With both the x and y component of velocity found, we can find the magnitude of the resultant velocity by using the Pythagoras theorem. Substitute in the values and you get the answer. Now, we will need to find the direction of the motion, in other words, the angle of the velocity. Applying your knowledge of trigonometry, you should be able to get the angle. As the value for Vy is negative and Vx is positive, hence the direction of the velocity is 41.41 degrees below positive x-axis. We are now done with question 1, so let's jump into question 2. Similarly, we can extract several information from the question itself and they are all listed at the side here. Part A of this question is pretty straightforward. The question wants you to find the time taken t when the ball strikes fairway and the sx of the motion. Similar to question 1 just now, we will need to use the linear motion equation s equal ut plus 1 over 2 at squared and the information for the y-axis to find the t. Substitute in all the values and rearrange it. You will get your t equals to 1.0 second. In order to find the sx, we will be using the same linear motion equation but using the information for the x-axis. Substitute in the value and you will get the sx equals to 20 meters. Part B of this question requires you to calculate the speed of the ball at t equals to 0.8 seconds. Unlike the part C for question 1, you don't need to find the direction as the speed is a scalar quantity. This means that it only has magnitude only. In order to solve this question, we'll be required to resolve v into x and y component. Like I have mentioned earlier, the velocity for x component is constant throughout the motion. Hence, vx is equal to ux, which equals to 20 meters per second. To find the y component of the velocity, we'll be using the linear motion equation v equal u plus at. Substitute the information for the y component and you shall get your vy equal to negative 7.848 meters per second. With both the x and y components of v found, using the Pythagoras theorem, we will be able to find the speed of the ball, which is equal to 21.48 meters per second. Now we are done with question 2. Let's proceed to the last example question. As you can see from the diagram here, the ball is projected at an angle. Hence, you will need to resolve the initial velocity u into x and y components. I'll list all the information that you can obtain from the question at the side here. Without further ado, let's proceed to part A. Part A asks for the time taken t for the ball to hit the wall. As usual, with adequate information given from the question, we can solve it by using the linear motion equation s equal ut plus 1/2 at squared. Substitute the values into the equation and rearrange it. You should be able to get t equals to 3.92 seconds. Part B of this question requires you to find the distance between P and the position of the ball striking the wall. In simpler words, it wants you to find the vertical displacement Sy as P is the same level as the initial point. In order to solve this, we will need to use the linear motion equation s equal ut plus 1/2 at squared. Substituting the value for y components, press your calculator and you should be able to get your answer Sy equal to 24.98 meters. Finally, part C. This question is exactly the same as part B of question 2. First, we have to find the x and y components of v. Finding vx is pretty straightforward. You just have to get the x component of the initial velocity, u, and you will get vx equal to 15.32 meters per second. For vy, we'll be using the linear motion equation v equal u plus at again. Substitute in the value for y component, press your calculator, and you'll get vy equal to negative 25.6 meters per second. In order to find v, we'll be using the Pythagoras theorem, substituting vx and vy into the equation, and we can get the answer v equal to 29.83 meters per second. Alright, this is the end of my video. I hope you have learned something from it. Thanks for watching.